Hello and welcome to the lesson on distributive property. Please make sure you have your notes paper for today, and at the top of your notes paper there is a space for you to solve or do the LOT. So please pause the video and do that, and when you are ready to check your answers, press play. Alright, welcome back. Let's check our answers here for the LOT. What I see in this LOT is what we did yesterday in class. It looks like it is combining like terms. I see in the first question negative 8 over 3x minus 4 over 3x. The first thing I see is that they both have the variable x, so they are like terms and I can combine them. If I think about keep, change, I also notice that they are both negative, so I am going to add them together and keep them negative. I notice that they already have a common denominator, so I do not have to worry about that. So 8 plus 4 is 12. Keep the denominator, keep the variable of x, and keep the negative sign. Now I do notice that that is 12 over 3, and 12 divided by 3 is the same as 4. So I'm going to simplify that to negative 4x. On the second one, I see a bit longer of an expression. I see n, and then I see two constants. So I'm going to combine 2.2 and 0.4n, adding those and being sure to line up my decimals as I add. And I get 2.6, so 2.6n. Then I'm going to do negative 1 plus 2, which is the same as 2 minus 1. So I'm going to have a plus 1 at the end there. Now this last one can look nice and complicated at first, but remember like terms is looking for the exact same variable. So I see a 5y to start. So I'm going to look for any other y. I see a second one there and a third. So I have three terms that have the variable of y. Then I'm going to look at my next term, 5x squared y. I notice that the exponent is on the x, and I do not see any other terms with an exponent on the x, so I'm going to move on. Then I see negative 7xy squared with the exponent on the y, and I see another one here at the end, 3xy squared. So those are going to be like terms that we put together. 5y minus y, I know there's a 1 there, so 5 minus 1 is 4y, but I still need to add this 5y that's over here, so plus 5 more gives me 9y. I do not have any terms to put with the 5x squared y, so I'm going to copy that to my answer. And then the negative 7xy squared plus 3xy squared. I see negative 7 plus 3, and so when I see those different signs I subtract and end up with negative 4xy squared. So let's continue on to our objective for today. Today our objective is that all you mathematicians will use the distributive property to simplify expressions. So the distributive property is our new piece here today. It is still simplifying expressions, but instead of combining like terms, we are distributing today. So what is distribution? If we think about a real life situation, as you can see we have some pictures of Walmart here. There is something called a distribution center, and in terms of stores, that is where all of these supplies, all of the items that are sold are kept. So the warehouse is huge. It contains all of the items that Walmart might sell, and they distribute the items to other Walmart stores across the country. If the Walmart in Goshen and the Walmart in Mishawaka do not receive the same items, they might not be very happy. If there's a special Christmas deal on a TV and Mishawaka gets all of them and Goshen gets none, then Goshen won't make any sales on that TV. So they are losing out. So it's important to think about with distribution that items are shared evenly or shared equally among the other stores in this case. So how does that apply to math? Well, if I think about the distributive property, to distribute means to give something to each member of a group. Okay? So, for example, if I'm going to distribute candy in class, I would it would be fair to distribute to every single student in the class. If I only distributed to the girls, because I am a girl and girls rock, then the gentleman in the room would not be very happy with me. So when we distribute, we need to think about giving something to each member of the group. So in terms of math, if you look down at the bottom, we see an A on the outside. Notice that there is no math operation, so that math operation there is multiplication right here between the A and the parentheses. So I'm going to multiply A times B, and I'm going to multiply A times C. That leaves me with AB, or A times B, plus A times C. So let's take a look at what that looks like actually mathematically when we have values in there, not just variables. Okay? So when I look at the distributive property, I see a number outside of the parentheses. It's important to verify that that number is being multiplied. If there was a plus sign or something in there, then this distributive property would not apply. So as I see this, I see 3 times with those parentheses there, x plus 7. So I'm going to distribute the 3 to everything in the parentheses. 3 times x is 3x. 3 times 7 is 21. And that is my answer. That is as simplified as it can be at this time. In the next one, again, I see 2 right beside the parentheses, so it is multiplication. So when I distribute, 2 times a is 2a. And 2 times 4 is 8. All right, so check this out with me, and if you feel comfortable pausing it and trying these first, you may do so. In number 3, again, you should be following along on your notes, filling in the boxes accordingly. The boxes are numbered for you to follow along. I notice in number 3 that the 5 is on the opposite side of the parentheses, and that is okay because it still follows my qualifications of being a value multiplied by a quantity in parentheses. So I am still going to distribute. 5 times 3 is 15, and 5 times the letter k is 5k. Now with variables, it does look confusing, but it is still times there. So a times x, or x times a, is xa, and x times m is xm. So what happens if that math operation inside of the parentheses is subtraction instead of addition? I don't know if you noticed, but in the first several problems it was all addition. So let's mix it up here. What happens when we have a subtraction problem? So as we look here, my distribution does not change. My thinking stays the same. 2 times x is 2x, but with that minus sign or that negative sign, my symbol in my answer is going to also be that negative or that minus sign. 2 times negative 5 is 10. As I look here, again, distribution, I do see a minus sign there, so I need to watch out. 3 times 5 is 15, and 3 times x, or times negative x, is negative 3x. On the last one, I notice that 3 is at the back, but I'm still going to distribute. 3 times x is 3x. 3 times negative 5 is negative 15. Now, you'll notice here we are distributing a negative number. We are distributing a negative number. So my process still does not change, but I'm going to have to think about integer rules and be very careful. I am distributing a negative 2. So I'm doing negative 2 times x. That leaves me with negative 2x. And then for the second piece, I'm doing negative 2 times a positive 7. Well, I know 2 times 7 is 14. When I look at the signs of that, I know it's a multiplication problem, so if I need to draw Mr. Multiple Vision, I can. A negative times a positive leaves me with a negative answer. So negative 2x minus 14, or negative 2x plus negative 14. Okay, let's practice a couple of those. Again, if you feel comfortable, give it a try and then press play when you're ready to check. On these problems, we do want to be careful because I see both a negative sign on the outside and a subtraction sign on the inside. So I'm going to watch out here as I do my problem. Distributing a negative 3. So negative 3 times x is going to give me negative 3x. For the second part of my distribution, I'm doing negative 3 times, and this term is a negative 4. I see two negative signs, and I know in multiplication that means I end up with a positive, and 3 times 4 is 12. So notice that subtraction sign does not always stay, specifically if I'm distributing a negative sign. So let's take a look at the next one. Negative times 3 minus x. Now this one at first might look confusing, but what I want to remind you is that when there is no number, there is an invisible 1. So in number 10 here, we are distributing a negative 1. So negative 1 times 3 is negative 3. And negative 1 times negative x, negative times a negative makes a positive, and 1 times x, you can either write it as 1x or you can just write the x. Negative 3 plus x would be my answer there. Now, these questions are where students start to get a little bit nervous. Remember, we are trying to become more comfortable and confident with rational numbers. So as we do this, please follow along with me, take the notes on your paper, and do the best you can. Okay? The distribution does not change. I'm distributing a 2 in the first question here. Now, here's where I have to stop and think. 2 times 5 over 3k. Well, I know that the k is not going to change. There's actually another multiplication sign there, so I'm going to focus on the values, focus on the numbers themselves, the coefficient and the constant. And I remember that when multiplying fractions, I do not have to have a common denominator, so that's nice. I can just multiply straight across. 2 times 5 is 10. 3 times 1 is 3. And I keep my variable k with that term. For today, you can leave it improper, so I'm going to leave it as 10 over 3k. And then I'm going to come back to my original problem and make sure I did the whole thing. I have not yet. I also need to distribute 2 times the negative 1, the second term in the parentheses. Positive and negative number gives me a negative answer. 2 times 1 is 2. So my answer for number 11 is 10 over 3k minus 2. In the second one, again, distributing a 3 here. My first piece is 3 times negative 11 over 3m. Well, when I multiply these fractions, I do actually see that, first of all, I can simplify diagonally. So both of these 3's can be divided by 3 and become 1. So 1 times negative 11 is negative 11. 1 times 1 in the denominator is 1, but I don't have to write that down because I don't ever have to write down that over 1 if I don't need to. And I can't forget that the variable m was with that. So when I distribute a 3 to that first fraction, the fraction actually canceled out. When I distribute the second one, 3 times 5 over 2, this one does not look like it's going to cancel out because I cannot simplify diagonally. 3 times 5 is 15. 2 times 1 is 2. There were no negatives involved there, so it is going to remain plus or positive 15 over 2. So negative 11m plus 15 over 2. All right, at this time, I hope that you as mathematicians in my classroom feel comfortable and confident to use the distributive property to simplify expressions. At this time, if you would please show your completed notes paper to the teacher so that you can receive your practice assignment, and that would be great.